CS687 Capstone AWilkinson, video number 2 of 6 total. Related work. Use of the convex hull has a long history, dating back to 1957. Cronin, reference 4, wrote, in 1957, Barichet, reference 5, proved that there exists an optimal tour which preserves the relative order of the points on the convex hull. Approach. Complexity induction methodology or theory is best described by the concept of complexity introducers. When the normal projection of a merge point candidate lies on line AB segment, meaning on or between points A and B, then a low complexity is introduced into the system. When a merge point candidate normal projection onto the AB line lies on a point outside of segment AB, then appreciably more complexity is introduced into the system, and a switchback or fold is created. The amount of complexity introduced into the system can be related to the severity or the angle of the switchback or fold. Approach continued. A plot was developed for pursuing parameters that might be used in the code to characterize severity of complexity induction. These parameters would be multiplied by the resultant delta distance from a candidate merge. The equations developed for best fit curves were used in Excel to plot candidate merges. In the data point plots shown, a delta distance merge only is compared for the two different candidate merge points, and a delta distance times a created complexity induction parameter is shown. In this plot, the delta region D merge, which is the merge outside of the line segment but on the line, would be selected based on delta distance after merge criteria only. However, when the standardized complexity induction parameter is applied, the candidate merge point whose projection would lie on segment AB is selected. Approach continued. The plot indicates that switchbacks can be avoided using complexity induction, which at this time in the investigation the researcher thought was always good, but later results indicate that sometimes formation of minor, non-severe angle switchbacks is preferable when trade-off with delta distance is minimal. The concept of earlier sacrifice for later gain now comes into play. Consequently, this plot is considered significant in the investigation, but at the time it was considered significant for perhaps the wrong reasons. Approach continued. Many plots of this type were made using the curves on the left side of the slide, and documentation was made. Researcher was still of the opinion that avoidance of switchbacks was the goal using feedback input parameters and complexity induction. Complexity induction theory at this time was in early stage development. Approach continued. These findings provided encouragement to move forward with code writing. The axis values and lines equations were only used for this particular Microsoft Excel-based study. The overall curve represents a way of incentivizing or de-incentivizing switchback creating merges. The previous slides depict proof of concept work. The equations were relegated to concept development status and were not used for code development. A simplified complexity induction algorithm was written. Input parameters either, again, incentivize, encourage, or discourage switchback creating merges.